A particle moves along a straight line for the time interval 0 to 5, including endpoints here. Okay? The velocity of the particle is given. So I gave you velocity. And the position is given by s of t. It is known that s of 0 equals 10. Okay? So at this point, if it was me doing this question, I would type this into my calculator. Into the y-list, yeah. Not saying that we're going to use it in part A, but we might, and we might not use it at all. But it's a good idea. Okay. So velocity is -2 plus t squared plus 3t to the 6/5 minus t cubed. And the position is given by s of t. All right, whatever. Part A, find the values of t in the interval 2 to 4 for which the speed of the particle is 2. Speed is what? Absolute value, right. So maybe I should write that down. Speed equals the absolute value of velocity. Now, there's a couple ways to go about it. The easiest way is to observe what's happening here. If speed is the absolute value of velocity, what's speed supposed to be? It says find the t values in that interval when the speed is 2. So I'm going to plug in 2 to speed. If speed is 2, then what's velocity? 2 or -2. So we are looking for when v of t equals 2 or v of t equals -2. It's a calculator-based problem, right? So you could, there's a couple ways to do it with your calculator. I would set that equation equal to 2, so what's it going to look like? 2 equals -2 plus t squared plus 3t to the 6/5 minus t cubed. Right? You guys okay with that? And then what's the other equation? Or -2 equals -2 plus t squared plus 3t to the 6/5 minus t cubed. I'm going to show you a couple different ways, okay? You hit the green button, and then copy is like the second one from the left on the top. Okay. So there's a couple ways of using your calculator with this, and this is important, okay? What could you do to solve this? Subtract 2 so it says equals 0, and then graph it and find the zeros, right? And then this one you'd have to add 2, and then graph that equation and find the zeros. And that's fine. In fact, go ahead and do that. Okay? So we'll subtract 2 here. We get 0 equals -4 plus t cubed plus 3t to the 6/5 minus t cubed. And on this one, we're going to get 0 equals, and that cancels out. What is it? T squared, thank you. So it would be 0 equals just t squared plus 3t to the 6/5 minus t cubed. Yeah, make sure you're looking at the interval between 2 and 4. So for this equation, you get t equals what? That's for this one? Yeah. 3 point what? 128. Is there any other values? Okay. So now just go back to your y list and then get rid of the -4. Right? Because that's this equation. Right, because you need to know when velocity is 2 and -2. 3.473? Okay, Brendan, they don't agree with you. We'll figure out where your mistake is so you got it right. Okay, so is there any other places? Okay, so our final answers are when t equals 3.128 and 3.473. The question is, in terms of bare minimums, how do you get your points? It's worth 2 points. That's it. So that's a lot of work for 2 points. You have to show that v of t has to be 2 or negative 2. Okay? And then you have to show your answers. All of this is, I'm not even looking at that work. I'm looking at this equals 2 or negative 2, and then the answers. Okay? 1 point for this, 1 point for that. If you just show v of t equals 2, and therefore t equals 3.128, you get 0 points. Because that means you don't know what speed is. Does that make sense? You're not getting 2 different speeds. You're getting 2 different times. Okay? All right, you guys got that down? Can I get rid of it? I just told you what the bare minimum was. This is a calculator problem. So you've got to express v of t equals 2, v of t equals negative 2. That's how you get 1 point. The second point is the answer. It's done. All of this doesn't matter, but if that's not there, you're probably not going to get the answer anyways. Okay. Yeah, we got a short amount of time left. So B, it says find all times in the interval 0 to 5 on which the particle changes direction. The particle, which is the original function f, I guess you could say, or x of t in this case, changes direction when what? When velocity changes signs. Okay? So this is velocity, right? So what are the points that we're looking for? Zeros and does not exist. Okay? You can plug in any t value. It can't change directions at an endpoint. Okay? So we're gonna set v of t equal to 0. So 0 equals negative 2 plus t squared plus 3t to the 6/5 minus t cubed. Is that where it changes direction? No. That is only when velocity is 0. What do you have to make sure? That the signs change. So first figure that out. That should be pretty easy because your function is already stored in your calculator, or at least a very close variation. 3.318? Wasn't that the answer to part A? No. Okay. Okay, 3.128. All right, is there any other values? That's the only time it equals 0? 0.536? Make sure your window is between 0 and 5 on this one. So, what is the answer? 0. What? 536 and 3.318. Do we agree? The next thing we have to do is look at signs. This is velocity, right? 0, 0. What is the sign? Because you're looking at the graph. What is the sign of velocity from 0 to 0.5? Negative. What's the sign between 0.5 and 3? And what's the sign from 3 on? Negative. Okay, so we could say the particle changes direction when t equals 0.536 and 3.318 since what? V of t, velocity, changes signs at these values, yeah, at these values. Okay, so that's your answer. That's a lot, trust me. Okay, so how are you going to get the 3 points? You're going to get 1 point for setting velocity equal to 0 to find your critical points. Okay? You're going to get 1 point for your answers, and then 1 point for the justification. Notice the number line does not give you points. It just gives you signs so you can get your answer. Does that make sense? Okay. Okay, so 1 point for setting v of t equal to 0, 1 point for the two answers, 1 point for the correct justification. Is the speed of the particle increasing or decreasing at t equals 4? This one's actually a pretty easy one. How do you know when speed is increasing or decreasing? Nope. Velocity and acceleration. The particle is speeding up when velocity and acceleration, same sign. It's slowing down when velocity and acceleration are opposite signs. And then notice it says at t equals 4. So let's do this. V of 4 equals, so you have it saved in your Y list. What are you going to type into your calculator now? Into your home screen, you're going to type Y1 probably, parentheses x, evaluated when x equals 4. Negative 11.476? Okay. Now, what is the other thing we have to find? The acceleration. It's a calculator problem, so you do not need to create the derivative on your own. You are just looking for the acceleration at t equals 4. So you can say, plugging in, you're going to type in the derivative of y1 of x, comma x, parentheses, evaluated when x equals 4. That's what you're typing in your calculator. 0.296. Okay, that's using your calculator. So we would say the particle is, well, the particles, I'm just going to use the same language that they said. The particle's speed is increasing when t equals 4. Since not v of t, since v of 4 and a of 4 have the same signs.
I would be pretty happy if I saw that question.
Yeah? It's worth 2 points, so it's going to... I believe it's going to be 1 point for the values of v of 4 and a of 4, and then 1 point for the answer with justification. So that's almost an entire FRQ from the AP exam, because they're only worth 9 points, and that's 7, so we're only missing one piece of that for the real thing. It'll deal with the other part on the real AP exam will deal with integrals.